everyone, welcome to another Data Vault Q&A. I'm again joined by our esteemed Data Vault trainer, Nols Eberson. Hey, Nols.
Hey, Julien, how are you?
Good, good. I have an interesting question for you tonight. So,
great.
We talk a lot about Data Vaults being able to be loaded in parallel. And so I wanted to ask, what does that actually mean? How do we go about building the scheduling and the orchestration and the loading of a data vault?
That's a fantastic question. And like all questions, it has a couple of layers. And so we need to understand, if we talk about parallel, it could be at the system level, it could be at the data flow level, it could be at an individual object level. And so as for the standards and what Data Vault has been teaching for a long time in the marketplace is obviously the parallelism is embraced as much as possible. And so this is about throughput, this is about independent processes, it's about minimizing wait states, it's about having a decoupled architecture. So we have principles like every source of data goes to, from a descriptive data perspective, goes to its own individual satellite, because of course, no two systems typically will have the same number of descriptors or the same type of columns or the same naming conventions. And so to lighten the integration load, they each get their own satellite. So they can run happily into their own satellite at whim. And so the frequency of which they arrive doesn't impact the patterns. So it brings great flexibility. Now, of course, if we start to look at these, they can run, if you then have separate satellites, separate targets, etc., then I don't care when the data arrives, it simply processes through, so that's not an issue. There is one little sticky question that sometimes pop up, and that is about, what about shared objects like hubs and links? Now, we've been teaching in Data Vault for forever that shared objects does not necessarily run in strict parallel fashion. So for instance, a shared business key or a shared hub will have a single object, and as while one job is running, it'll lock the table as it needs to, as it should, to insert the necessary components. That's fantastic. And then you go, well, strictly speaking, then nothing else can run at exactly the same time trying to insert the exact same values. And that is true. In fact, that's desirable, because who wants duplicates, which will then confound your reporting and accuracy and auditability? Then you can potentially argue that, hang on, that's not strictly parallel, and that is true, but it also has a couple of caveats around it. Think about it. How wide is a typical hub structure? It's a very narrow structure. It only inserts that which is missing or non-existent. So it executes in milliseconds in most platforms as such. Whereas that's not the holdback. That's not the bottleneck within the architecture. Look at your satellite. Hundreds of columns, billions of rows. Clearly, that's going to take a little bit longer to load than the hub. So if your hubs and links are not running absolutely true, perfect parallel into the same structure, it's inconsequential, because it will load in a fraction of the time it takes your descriptive details to load, which is where all the analysis is driven from and the values are coming from. And so within the context, if we say true parallelism, I'm thumping the theoretical perfect, what's a good word? The perfect theoretical possibilities, no. There's practical limits. We live in a physical world. We live in a world where science or physics still apply.
Yeah.
Let's use this as a bit of an analogy. So we've got a 6-lane highway going into Sydney, or Melbourne for that matter. I don't think Brisbane has got the 6-lane thing down yet, but that's okay. We're actually grateful for that. But here's the thing. You may have a bus lane. And so the bus lane, buses can only go one after the other, so it's like a hub, but there's no impediments for it, and they go fast. And so even in peak traffic, the buses zoom past everyone else, and the main bulk of the cars in the 6 lanes are crawling along at whatever speed is allowed given the time of day. And so that's akin to your satellites. So it's going to take a while for the car to get through before it gets to the other side. So if you know your traffic, then of course you're going to design and assign the tasks appropriately. So we've got a dedicated line for the hubs and links. Yes, they will have to be in something like a process pool. Most orchestration frameworks with this help, something like Airflow, Control M, and the like, well, you create a process pool. The process pool has a set of registered jobs in it. First in, best dressed. Whoever comes in first loads the data. Everything else that comes, they compare the available business keys to what already exists. If it already exists, nothing to do. And so their capacity to execute and conclude quickly goes up through the roof. And so that's the set logic. That's the mathematics that brings that performance through. So you have your business keys and relationships literally loading in seconds, whereas you'll take a minute or two to finish all of your descriptive data, all of your satellites. So by the time the data is actually available for consumption, everything is synced.
Yeah. So yeah, I mean, I'm not as technical as you, obviously. So let me understand if I've got this right. Everything runs at the same time. The satellites are all loading everything at the same time, but the hubs, we have a little constraint where the hub has to load in a sequence, and we apply that sequence, and you just do that through the orchestration.
It's not even a sequence. It's in order on which you arrived, or in the order in which you triggered. Now, most data flows in most organizations, even if they don't have this process pool mechanism in place, works just fine, because you have the nature of the data is they arrive at different times. So the actual chances or the opportunities for that lock to actually exist in the real world is negligible to inconsequential in most scenarios. Right. So, having a theoretical example of, say, let's take 10 systems all trying to load simultaneously. You want to tell me they all arrive through the same network at exactly the same time and exactly the same process? Unlikely. So even in less sophisticated orchestration frameworks, where you don't have a process pool and so on, the likelihood of actually having a collision, in other words, two values being written to the same structure at exactly the same time, trying to get a lock on the data, is already considerably low. Now, if you want to be sure, which some of us like to over-engineer, which is perfectly fine, we will put a process pool in place and therefore sleep tight, because that will never happen. So when you get out of bed, there is typically a infrastructure, network, or other resource catastrophe, not a process catastrophe.
Yeah, okay. So look, that great explanation. I love the analogy of a highway and, on the hubs of the bus lane. It makes a lot of sense, just allow them to carry passengers a lot quicker than the cars usually as well. So, it makes a lot of sense. So look, that's great. I think that helps answer a question that comes up fairly often. And I think it's a concept that a business user as well as a technical user can grasp hold of. So, thanks for the.
No problem. Happy to help.
We'll see you in the next one.
See you in the next one.